Hi, I-60 students. It's Miss Carol here. We're in the middle of a storm and my lights are doing something a little weird. So if they flicker on and off during this recording, you'll know why. We are still on Unit 3. We're now on Lesson 14. And we're still working on this redesign of the local community center. And we have 4 questions here. The first couple are very quick and easy. So let's go ahead and get started on those. Let me get this out of the way so I can read it. In the project for lesson 11, you saw the equation b squared minus 5b minus 150 equals 0, where b is the number of hours it would take Bativa to complete a playground model on her own. Solve the equation for b. So if you will remember here, we ended up with b. Let's see, we had minus 15 and b plus 10 equal to 0. Okay, that was our factored form. And then if we were to, the way that we can make this equal 0 is by setting either of these equal to 0. Because if this term equals 0, and I multiply 0 by b plus 10, I get 0. Or if b plus 10 equals 0, and I multiply 0 by b minus 15, I get 0. So by setting either of these equal to 0, I can solve for the roots of this quadratic equation. So I'm going to say b minus 15 equals 0. All right, well, how do I solve for b? I just have to isolate b. So if I add 15 to both sides, I'll get that b equals 15. Okay, so by the same token, if I say b plus 10 equals 0, I can isolate b by subtracting 10 from both sides, and I get b equals negative 10. All right, so let's just think about that for a minute. If I plug 15 into this equation, in for b, I get 15 minus 15 times 15 plus 10, and I want to make sure that's 0. Well, is 15 minus 15 0? Yeah. So then I have 0 times 25. Well, 0 times anything is 0, so that holds true. Let's see if it holds true. There goes my lights again. Let's see if it holds true for negative 10. So negative 10 minus 15 times negative 10 plus 10, and that is going to be negative 25 times 0. Well, that's 0. So that's what we're looking for. Essentially, we are looking for the places 15 and 10 where this quadratic equation is crossing the x-axis. So this would be negative 10 and this would be positive 15. Okay? So which of these is a viable solution? Well, we're dealing in time. This is a number of hours. We cannot have a negative number of hours. So the only one that works here is our positive 15. Okay, hopefully that made sense. Question 2, number 5, we determine an equation for the amount of time it would take Xavier to complete a community center model on his own. And so let's see, this was 12, lesson 5, and I did take notes, which I recommend that you do as well. And in that one, we had x plus 6 times x minus 20 equals 0. All right. Again, we want this quantity to equal 0, and we want this quantity to equal 0. So x plus 6 equals 0 when we subtract 6 from both sides, and x is negative 6. X minus 20 equals 0 when we add 20 to both sides, and x equals 20. Okay, I could plug x equal negative 6 in for x here, or I could plug 20 in for x, and I would get either 20 minus 20 and a 0 quantity there, or negative 6 plus 6 and a 0 quantity here, which would make this whole equation 0. So once again, we're dealing with time, so we cannot have a negative value, and our only viable solution is 20. Okay, so those were indeed quite quick. Let's move on to number 3. Explain how you arrived at your answers for the 2 previous questions. All right, so what we did was we set each factor equal to 0. Then we solved for the variable which is the root of the equation. Okay, so the only viable answers were the positive roots because we were dealing with time. Okay, so that's exactly what we did with those, and hopefully it makes sense why we could only choose one of those answers for each problem. All right, last question here. In the project for lesson 13, you solved an equation by completing the square. Explain how you would solve that same equation using the quadratic formula instead. Do you arrive at the same answer? So what we had was we had r squared minus 2r minus 24 equal to 0. And remember, our standard form is ax squared plus bx plus c equals 0. And hopefully in this lesson, you learned about the quadratic formula where our x values, and in this case it'll be r because our variable here is r, not x. So r is going to equal b squared minus, scratch that, minus b. I think I've told so many of you to commit this to memory. Minus b plus or minus the square root of b squared minus 4ac all over 2a. And the reason we're going to get 2 answers here is because we have a plus and a minus. Okay, so we definitely should get the same answers. If we don't, we're doing something wrong. So if you'll recall, our a value here is 1 because there's an implied 1 in front of the r. Our b value is a negative 2 right here. And our c value is a negative 24. Okay, don't forget the negatives. That's probably where most people mess up on these. Okay, so now I am going to plug these values into this equation. And I am going to actually scroll down to here, just so we have a little bit more clear space there. Okay, so minus b is actually a positive 2, okay, because minus a negative is a positive, plus or minus the square root of negative 2 squared is 4, minus 4 times 1 times negative 24, okay, all over 2 times 1, which is 2. So let's simplify this in here. I'm going to have 2 plus or minus the square root of 4 plus 96. 24 times 4 is 96, and these 2 negatives are going to make a positive, okay, all over 2. So r equals 2 plus or minus the square root of 100 over 2. So the square root of 100, fortunately for us, is 10. So this is 2 plus or minus 10 over 2. All right, well, this is actually not so bad. So one answer is going to be r equals 2 plus 10 over 2, and the other is r equals 2 minus 10 over 2, which this is 12 over 2 and 6. This is negative 8 over 2, which is negative 4. Okay, so to answer this question, we did end up getting the exact same answers, thank goodness. And our question here is explain how you would solve the same equation using the quadratic formula instead. Do you arrive at the same answer? Okay, so we definitely do arrive at the same answer, and thank goodness we should. We would use the quadratic equation by recognizing that A equals 1, B equals, let's see, a negative 2, and C equals negative 24. We can plug those values into the, and I should have written quadratic formula here. Plug those values into the quadratic formula, simplify, and solve for r. We do arrive at the same answer. One of our methods would have had an error if we did not. It's a good strategy to check two methods. Okay, that's it. I will meet you back here for lesson 15. Thank you for joining me.